Karyotype is a word that you've probably heard and remember from freshman bio, but just in case you forgot, stay tuned to the next minute. What is a karyotype? Well, a karyotype is a series of images of chromosomes copied and pasted into a larger image, forming a chart. It organizes chromosomes from largest, number 1, to smallest, number 22, and it looks like. Fun fact, chromosomes 22 are actually larger than chromosomes 21, but this was discovered after trisomy 21, commonly known as Down syndrome, was discovered. Scientists decided to keep the chromosomes where they are for the sake of keeping the name of the genetic disorder. Isn't that kind of cool? I thought it was kind of cool. Okay. Well, now, what you don't learn in freshman biology was that there's more than meets the eye to a karyotype. Chromosome arms, which as you can see here, they're like the chromosomal arms. I don't really know what else to call them, but so they're sorted as large or small. So the small ones are abbreviated as P and the larger ones Q. From here, each arm is further categorized and given a number. This system allows scientists to be able to describe certain chromosomal locations quite easily. But what is the purpose of just seeing a bunch of homologous chromosomes lined up by size? I mean, seriously, right? Come on. Well, it actually serves so many purposes. It allows geneticists and researchers to use genetics, to see genetic/chromosomal abnormalities and basically tell you what's happening with you. And specifically, you can see like insertion, deletion, and other significant mutations. An example of this is Turner syndrome and Down syndrome, trisomy 21. So here you can see both their karyotypes. See how different they are? They're insertion and deletion mutations. So this technique not only allows researchers to gain an understanding, but to predict and know the chromosomal complications of an offspring even before birth. Out of all the possible chromosomal disorders that can be seen in a karyotype, differences in the number of chromosomes is probably the most obvious. Well, you can imagine why, right? I mean, like, if I show you a missing chromosome, you're going to notice that before like a tiny little thing on a chromosome arm. Well, this is known as aneuploidy and is caused by non-disjunction during meiosis. Non-disjunction is where two homologous chromosomes fail to come apart either in meiosis 1 or meiosis 2. Wait 1 second and I'm going to show you the diagram behind me. Here's the diagram behind me. As you can see, the non-disjunction is occurring in meiosis 1. See, there's a failure to split here, so it's just like these two are sticking together, and it's just going there. And then that just continues out, and this is what happens. So you have the normal number of chromosomes minus 1, normal number of chromosomes minus 1, then you have the normal number of chromosomes plus 1, and once again, the normal number of chromosomes plus 1. So, as you can see, you have meiosis 1 is completely normal. Then you go to meiosis 2, and these two end up sticking together. So you have like these two go one way, and that one goes the other way. This is normal. So what you end up with is N. You were originally going to have 2, but now you have 1, so N minus 1. Now you originally were going to have 2, and now you have 3, so you basically just end up with N plus 1. That's it. That's it, guys. Woo! That's it. can't dance, but I love to dance.